In this video, we're going to discuss the shapes of the distributions of data and discuss what summary statistics best go when looking at a particular shape of data. So our central question today will be, how can I use the shape of the data to help me summarize it? So before we dive into this, we're going to need to go back and really kind of single out some of our best summary statistics. So over here in the left-hand column under questions, let's go and write some of the things we've gone over already. We have our central tendency statistics. And those are our three main ones from our last chapter, which would be mode, mean, and median. And then we have what we've been going over in this chapter is our dispersion statistics. Which would be our standard deviation, range, variance, and interquartile range. Which we will abbreviate with the IQR. So we're going to need to have these kind of at the forefront of our minds when we're actually going to describe or summarize statistics. So in our first distribution, a symmetric distribution, data is evenly distributed. And what that means is I have an even amount of data kind of to the left and to the right, and my mean is really close to my median, where everything is very symmetrical on both sides of the mean, as you can see here in this histogram. Our best summary statistic for these will be our best central tendency will be the mean. And our best dispersion, I'm abbreviating, is the standard deviation. So now when we have a data set that is skewed right, like we have here below in our next picture, let's go ahead and draw a line to separate. A majority of the data is clustered to the left with a tail of data to the right. So the best way to help yourself remember if it's skewed right is look for the tail of data. So this tail, this long tail of data kind of trailing off from where a majority of my data is clustered, that trailing off right there is on the right hand side, so that tells me it's skewed right. And to describe this statistic, our best central tendency to use will be the median. And the best dispersion is the interquartile range. Now, skewed left is quite similar to skewed right, except it's just the opposite. So a majority of the data data is clustered to the right with a tail to the left. So whenever you're using this skewed idea, look for the tail. Tail on the left, skewed left, tail on the right, skewed right. And the summary statistics are the same as our skewed right. Our best central tendency will be the median, and the best dispersion statistic is the interquartile range. So now let's look at some examples of these. So we'll go ahead and flip over. For this first one, let's make a histogram to plot the data. It's always important to somehow plot this data so you can really have a visual indicator for our skewedness. So what I'm going to do is I'm going to zoom in on where I'm actually drawing the histogram, but I'm just pulling on the information from this table right here. So I'm using this table to build this histogram. Okay, so I'm going to leave some space. I'll put my 9 here, 10, 11, 12, 13, 14, and 15. And then going up, I'm going to count by 2s for my frequency. So I'm going to start with 2. I think we have enough. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and that'll be 21 at the very top. So we'll build our bar graphs, a histogram. So we'll have at 3, we know that the shark length is 9 feet. So we have 3 sharks that we caught that were 9 feet. So we'll draw a bar graph. Then for the 10 feet, there's a 9. So we'll go up to 9. Draw that bar graph. Then I have sharks that are 11 feet. There were 20 of those caught. Like so. Then 21 for the 12. Like so. Then 18 for the 13. Like so. And then 10 for the 14. Like so. And then 15 for the 2. When we look at this shape of the distribution, it's kind of like you have to use what you think is best. And I see that I have my tallest bar in the middle with similar bars on either side. So my best would be to say that this one is symmetric. And we use a histogram to look at that. On the next problem, what I'd like to show is a dot plot to look at this one. So dot plots are where we just draw a number line. Instead of drawing bars, we're going to use dots to indicate all of our the frequency. So if I have 0, 1, 2, 3, 4, 5, 6, 7. This is for our goals scored. And then our frequency, we'll just place a dot for every time that to indicate the number of frequency. So for 0, since there's a frequency of 4, I'd put 4 dots. And so on and so forth. For 1, since there's a frequency of 8, I'd use 8 dots. 2, there's 5. 3, 3 dots. 4, 1 dot. 5, 1 dot. 6, 0 dots. And 7, 1 dot. And now the dot plot, just like a histogram, helps us see a skewedness. So we can say that this is skewed since my data is clustered to the left and I have a tail to the right. We're focusing on the tail to describe the skewed, so we can say skewed right. So in number 3, what we want to do is just kind of identify what the skewedness of it is, determine which measures of central tendency and dispersion best represent the data. So for number 3, we just want to say, well, it's skewed right, my tail's to the right. And then my best central tendency when I have a skewed graph is my median, and my best dispersion is my interquartile range. And that's how we can just briefly discuss what would I use if I was really trying to dive into this data set. So next I have this, for number 4, is estimate the percent of data within one standard deviation of the mean. So here we're going to really use that standard deviation, and the standard deviation is already given to us. And what this is telling me is that if I want to estimate the percent of data within one standard deviation, I want to focus in on all the information that's in one standard deviation of the mean. So if my mean's 4, everything that's one standard deviation within that would be between 3 and 5. Because I'd go 1 away from 4, that's 3, and I'd go 1 away from 4 in the positive direction, that's 5. So I want to kind of compare all this data in here to all the data. So if we we can look at all our bars and we can get all of our information from there. Well, I have 12, a frequency of 12 in my 3 column, then I have a frequency of 15 in my 4 column, and a frequency of 7 in my 5 column. And I'm going to compare that to all the data in the graph by dividing it. That way I can get a percentage, and that will tell me the percentage of data that is in between 3 and 5 within one standard deviation of the mean compared to all the data. And then if we look at all our columns, we can see that there's 5 in the 1 column, 8 in the 2 column, 12 in the 3 column, 15 in the 4 column, 7 in the 5 column, 6 in the 6 column, and 2 in the 7 column. And this is, so what we're really doing is saying what we're interested in divided by our total. And we get 34 over 55, which is approximately 62%. And that's how we can use these, our different statistical ideas to help us summarize statistics and use the skewedness to kind of help us look at the data that we gather.